All right, family. Welcome to Algebra with Mr. Peters. Today we're going to be doing our first live stream for 2025. Want to tell you guys thank you so much for joining us today. We're going to go over about 14 problems, and the topics that we are going to focus on are going to be absolute value equations and inequalities. We're also going to touch on quadratic equations and applications, and then we're going to finish up this video with radical operations or operations with radicals. So if you have any questions, just please make sure you hit the chat for us. We're going to be trying to respond to any questions or concerns. And if there's any video topics that you guys would love to see on our channel in the future, just please also comment down below so that we can know as well. So when we're talking about absolute value equations, family, we have to understand the basics before we get over to the inequalities. And typically we're talking about the distance from zero on number line. So when we look at this first equation, the absolute value of x minus 3 is equal to 5. Remember that we're going to create two equations. Number one always stays the same. So once we drop the brackets, the equation is the same. X minus 3 is now equal to 5. After we add the 3, we know x is equal to 8. And then once we repeat the process, right, absolute value of x minus 3 is now going to be equal to negative 5. And then once we drop our brackets, we'll have x minus 3 is equal to negative 5. And then once we add 3, we know that x is going to be equal to negative 2. So that's the basics when we're talking about absolute value equations. But our focus is going to be on the absolute value inequalities. And we're going to touch on the two scenarios. So scenario number one is when we have a greater than sign. So when we have this greater than sign, that means we're going to have an or statement. So first absolute value equation, inequality, I'm sorry, is going to stay the same. And the second one, or, we're not only going to change this to a negative 2, but we also have to make sure that when we're doing these type of problems, that we also flip the sign. So now it's going to be less than negative 2. So we repeat the process, we drop the brackets. So now we have x minus 5 is greater than 2. So we know x is going to be greater than 7 once we add 5 on both sides. Then on the opposite side of this, when we're solving the second equation, we have x minus 5 is now going to be less than negative 2. So when I add 5 on both sides, we have x is going to be less than positive 3. So this is just the basis when we're talking about greater than sign. Now, the next two problems, this is where students typically struggle, which is the less than. And the reason why they struggle is they kind of forget how to set it up. And I'm going to show you two ways. So the first way is really the simple way, which is just to split the inequalities. So we have the absolute value of 2x plus 1 is less than or equal to 7. So once we drop our brackets, this is what we'll have. We'll subtract 1. So we have 2x is now less than or equal to 6. And we know x is less than or equal to positive 3. Now, when we do the second inequality or equation, all right, we have the absolute value of 2x plus 1, but now it's going to be greater than or equal to negative 7. So we drop the brackets, 2x plus 1 is greater than or equal to negative 7. So we'll have 2x is greater than or equal to negative 8. And then we're going to get x is greater than or equal to negative 4. Now, the easier way and the way that you guys should learn this so that you don't make any mistakes expressing your answer is to do it the way that I'm going to show you. Because typically with the less than inequalities for absolute value, we're going to get a compound inequality, which is going to be an and statement. So let's say we look at this second problem, right? The absolute value of x plus 2 is less than 3. What we're supposed to do is, let's write this out first. So we have the original problem. And then on the left-hand side of the equation, we're going to put the second inequality. So not only do we make it negative, but the sign is going to stay the same. So we don't flip the sign when we use this method. Oops, put the wrong number, family. I'm sorry. It's about 3. So after we set this up now, this is basically the format. And once you understand this, it makes these type of absolute value inequalities a lot easier to solve. So we drop it, and this is what we should have. So we have x plus 2 is greater than -3 and less than 3. So we want to get x in the middle by itself. So we're going to subtract 2 from itself and our two outside quantities of -3 and +3. So once we do this now, we're going to get this is what we're going to get. X is now greater than -5 and less than 1. And I wanted to show you guys, if you split it, you're going to get the same answer choice. And this is why I prefer this method. So let's say we split that absolute value, right? Once we drop the brackets, it's the same exact thing that we're going to get. X is less than 1 for the first one. And then we'll repeat the process, right? Absolute value of x plus 2 is now greater than -3. Once we drop the brackets, right, we subtract 2. We have x is greater than -5. And that's what this statement is basically saying in the red. So either way is going to work for you, family. Just pick the best method for you. And I would typically tell you to know both of them. Now, when we switch over to our second topic of the night, we're going to talk about quadratic equations. And I'm going to tell you that this is probably one of the most common topics on the exam. And then let's see something real quick. So when we have a problem like this, right, the question wants us to determine which of the quadratic equations will give us this factorization. And this is pretty simple. All you have to do is FOIL this back. So I typically will use the box method, right? This is just if you're not good with foiling or you sometimes mess up. So we have x and -3 on the top. That's what's in parentheses, and x and -2. So when we go through and multiply, we have x squared, x times -3 is -3x, x times -2 is -2x, and -2 times -3 is going to give me a +6. So once I combine my like terms, we'll have x squared minus 5x plus 6 is going to be equal to 0. So anytime they give you this factorization, all you need to do is multiply it back so that you could get the correct quadratic equation. So the answer choice here should be answer choice A. Now, before we go to the next question, let's say they had it like this, where they said x is equal to +3 and then x is equal to +2. So if they gave us the actual zeros, it's the same concept, meaning we have to work backwards. So if x is equal to 3, when I subtract x, I have x minus 3 is equal to 0, which is that first factor. So this is my first binomial. And then if x is equal to 2, if we work backwards and subtract 2, we're going to get x minus 2 is equal to 0. That's how we get x is equal to 2. So if they give you it as a binomial expression, x minus 3, or if they give you the actual 0, x is equal to 3, just understand how to get back to the binomial and how to multiply to get the full quadratic equation. All right. Let's go on to the next one. So this next problem, let's see, this next problem now, what's going to happen is they want us to use the quadratic formula to basically solve this one. And I'll be honest with you, family, we don't have to use a quadratic equation because we are going to get a whole number. We typically use this when our answer is not expressed as a whole number. But for the video's sake, we're gonna do it. So we know the quadratic equation. Let's bring it up. So x is going to be equal to the opposite of b plus or minus the square root of b squared minus 4 times ac all over 2 times a. And just remember, with these type of problems, it follows the standard form of quadratic equations. So ax squared plus bx plus c. So we know c is 6, b is -8, and a is 2. So now when we come down to substitute, we have x is equal to the opposite of b, so the opposite of -8 plus or minus b squared. So that's 8 squared minus 4 times a, which is 2, times c, which is 6. And this is all divided by 2 times a. We know a is 2. So this is just the first thing that we kind of have to do, family. So we substitute. Now we simplify. X is equal to positive 8 plus or minus 64 minus 48 all over 4. So if we bring this up over here, what we're now going to have is x is equal to 8 plus or minus the square root of, and I want to say this is 16 once we subtract. Let's just double check. Yep, plus or minus the square root of 16 all over 4. So we can simplify this radical, right? It's a whole number. So once we simplify, we'll have x is equal to 8 plus or minus 4 all over 4. So when we simplify our answer, the first x is 8 plus 4 is 12. 12 divided by 4 means x is equal to 3. And then for the second choice, we have 8 minus 4, which is 4. 4 divided by 4 is just 1. So the second x is equal to 1. So this is how we would solve if we were dealing with the quadratic formula. But if it was me, family, this is the best way I would tell you guys to solve it. So let's come down here in blue. So we have 2x squared minus 8x plus 6 is equal to 0. So if you noticed right now, all three of these numbers, we could pull out a GCF. And the GCF that we want to pull out is going to be 2. So when we factor out a GCF of 2, we're left with x squared minus 4x plus 3 is equal to 0. And now we just want to kind of focus on what is inside of this parentheses to finish factoring the problem. So when we continue to simplify, we're going to have 2 times x minus 3 times x minus 1. So now we set our factors equal to 0. 2 is equal to 0. That's incorrect. So we toss that 1 out. X minus 3 is equal to 0. So we know x is equal to positive 3. We already identified that x. So we know this is correct. And then the second one, x minus 1 is equal to 0. So we know x is equal to positive 1. And this is why it's so important for us to kind of understand the different methods when it comes to solving the absolute, I'm sorry, not absolute, but solving quadratic equations. It's always good to make sure we have more than one, more than one method. I'm sorry, family. All right. So next equation we're dealing with quadratic equations. They give us another one where we have a lead coefficient of 3, but we're not going to use the quadratic formula to solve. I want us to focus on using the AC method because I get a lot of questions and video requests of how to factor or just easy factoring methods when the lead coefficient is greater than 1. And I'm going to tell you guys, if you use the AC method in group factoring, this is going to become 10 times easier. All right. So with this AC method, we're going to multiply A and C to get 27. And we know whatever factors we use, we have to add to give us negative 12. So off the rip, family, I'm already thinking 9 and 3. I know it multiplies to give me the 27. When we add, it's going to give us 12. And if we want a negative 12, they just both need to be negative. So we come on in here now, and when we substitute, right, we have 3x squared, right, minus 3x minus 9x plus 9 is equal to 0. And once we're right here at this step, this is when we want to start grouping our terms. First two, last two, always leave out that negative sign. So we're going to pull out a 3x, we're left with x minus 1. And then when we do this for the second parentheses, let's say we pull out a 9. We're left with x minus 1 again is equal to 0. So we already know, due to the what's inside the parentheses, both of them are the same. So this is going to be correct. So we have x minus 1 is our first factor, and our second factor is 3x minus 9 is equal to 0. So once we solve, right, set them equal to 0, we know x is equal to positive 1. And then the second factor, 3x minus 9 is equal to 0, meaning 3x is equal to 9 when we add it. And after we divide, x is going to be equal to 3. Now, I get a lot of questions, and you guys may not have it right now, but students always want to know, what if I write or put these two factors in a different order? And I'm going to tell you guys, it does not matter which one comes first. We're typically always going to get the same answer. So let's say I go back to the first step. We have 3x squared, and now I substitute, but I put 9x first, then minus the 3x, then finish off with plus 9 is equal to 0. So if we did it this way and we had the 9x first, we're still going to simplify and get the same answer. So when we simplify the first one, we're going to pull out 3x, left with x minus 3. Then when we go to the second set of parentheses, I'm going to pull out a 3 again. Now I'm left with x minus 3, and this is equal to 0. So now when we simplify, we have x minus 3 is equal to 0, meaning x is equal to positive 3. We already had that answer. And the second one was outside of the parentheses, we have 3x minus 3 is equal to 0. So we're going to get 3x is equal to 3. And once we divide, we know x is going to be equal to 1. So when you use this method, it doesn't matter which factor you substitute in first or second. It's going to give you the same exact answer. And I wanted to prove that to you guys. Now, when we go on to our next example in this live stream, I need you guys to really understand this concept, like seriously, because they're always going to ask you quadratic applications every EOC. So they tell us that a ball is thrown into the air with an initial velocity of 32 feet per second from a height of 4 feet. The height of the ball after t seconds is given by the equation. And they want us to determine the maximum height reached by the ball. So here's the function. Because of this negative sign, guys, we should know that our parabola is opening down. So the object is going to look something like this. It's going to have a U, basically an upside down U or N. It's going to be a shape like this. And basically what they want us to identify is this point right here, the highest point, which is also known as the vertex. And for us to find the vertex for any quadratic equation function, the x coordinate is always equal to the opposite of b divided by 2a. So when we look here, we know that b is 32. So x is equal to the opposite of 32 divided by 2 times a. We know a is negative 16. So the x coordinate for our vertex is negative 32 divided by negative 32, meaning x is just equal to positive 1. So this is not our correct answer choice. This is just the x coordinate. So when we look over here now, what we want to do is substitute this back in. Because what we have is just a time. So at 1 second, right? Because remember, t represents second. So at 1 second, that's when it reaches highest. And now what we're trying to determine when we plug in 1 into the function is what is the y? What is the actual height? So now that I plug this in, right, we have h of 1 is equal to -16 times 1 squared plus 32 times 1 plus 4. So we know after 1 second, we're going to get -16 plus 32 plus 4. So we know h of 1 is going to be equal to 16 plus 4. So we know h of 1 is going to be equal to 20 feet. So this would be our answer choice. And when I look at my answer choices, all right, looks like I may have copied the wrong answer choices. So we're not going to pay attention to this. All right, I put the wrong answers there. I'm sorry. But the correct answer choice is going to be 20 feet. And he's going to reach that 20 feet after 1 second. Now, another question that they typically are going to ask you guys is going to be, what is the initial height of the ball? And typically in the question, they're not going to tell you like they did in this one. But all you have to do is to substitute in 0. So we're talking about at 0 seconds before we probably even threw or launched the ball. And once you substitute, right, we'll know that h of 0 is going to just be equal to 4 feet. So we know initially at the starting point, the ball was 4 feet above the ground. And just to give you a rule of thumb, it's typically just whatever that constant is. So whatever the constant is in the quadratic equation is typically going to represent the initial height. And before we go to the last problem, just always remember they're going to ask you guys to interpret the answer. And I've said this before, but we should know that with this problem, they're going to reach their highest height, which is 20 feet, exactly 1 second after throwing or launching the ball. So if they ask you to interpret what the vertex represents, this is how you would do it. All right. So I believe this is the last question for quadratic equations. And one concept or skill that they want you guys to always demonstrate is how to complete the square. So with this problem, we're kind of lucky because the lead coefficient is already 1. For us to complete the square, we have to make sure the lead coefficient is 1. Now that it is, right, let's just rewrite this. We have x squared plus 6x plus 5 is equal to 0. We're going to move this 5 over to the other side. And just remember, when you're also completing the square, this is the same concept as going from standard form to vertex form. So if you get confused, I want you guys to understand completing the square and going from standard form to vertex form is the same thing. So x squared plus 6x, this is equal to -5. And for us to find or complete the square, there's 2 key things. We need to know, oops, wrong variable, b divided by 2, that's 1, and b divided by 2 squared. Now, I'm going to put this little quick note right here. And then, matter of fact, instead of trinomial, let's put binomial. So anytime that you want to figure out the C term, you're going to go to the second expression. So we take half of the B term. B is 6. So 6 divided by 2 is 3. 3 squared is 9. So this is how you find the C term, and we have to balance the equation by adding it on both sides. So from here, right, the right side simplifies to positive 4. Now, for us to get from this trinomial to the binomial that gives us this expression, we just have to take b and divide it by 2. So 6 divided by 2 is 3. So when we do x plus 3 squared, right, when we multiply that by itself and FOIL, that's what's going to give us the trinomial. So at this step, we're done. We have x plus 3 squared minus 4 is equal to 0. So now we've completed the square, and this is in vertex form. So our correct answer is going to be answer choice A, right? But before we go to the next problem, 2 things. Number 1, if we were to identify the vertex, we know that is going to be HK, which is these two numbers that I'm highlighting. So the vertex would be -3, -4. Now, if for some reason they wanted us to kind of determine or figure out what the zeros are, all we need to do is pick that up at this step right here. So we have x plus 3 squared is equal to 4. So we're going to take the square root of both sides. Take the square root, cancel out the exponent, do the same thing on the opposite side. So we have x plus 3 is now equal to plus or minus the square root of 4, which is 2. So x is equal to -3 plus or minus 2. So this is how we're going to basically get our zeros. So x is equal to -3 minus 2, meaning x is equal to -5. And x is equal to -3 plus 2, meaning x is equal to -1 for our zeros. All right. So now we're going to go on to the last concept for today's live stream, which is going to be operations with radicals. And I think I've seen somebody's comment. If you're talking about derivatives, I could do that during our next live stream. So I'll take a note of that if that's what you are asking for. I believe I just seen your comment not too long ago. Just confirm that for me if you don't mind. All right, so we're on our last concept and we're talking about operations with radicals. So anytime we have a fraction, we cannot have a radical in the denominator. And when we have a problem like this is where we are going to multiply by what's called the conjugate. And just please understand the conjugate is the same expression or the same denominator with a different sign. So the expression is radical 3 minus 1. The opposite of that is just radical 3 plus 1. And when you remember your fraction rules, just remember that whatever you do to the bottom, you have to do to the top and vice versa. So the top part of this fraction now, when we distribute, we're going to have 2 radical 3 plus 2. And then on the bottom, if you understand the difference of squares, what happens is we just need to multiply the first two terms and the last two terms. So radical 3 times radical 3 is just the number without a radical. So that's going to be 3, and -1 times +1 is -1. So once we simplify, we're going to have 2 radical 3 plus 2 all over 2. And remember, we're dealing with fractions, and we are able to reduce. So when we look at this problem right here, we can reduce this. So we're going to have radical 3 plus 1. And this should be our final answer. And let's double check this real quick just to make sure. Yep, this is going to be the correct answer. Okay. So anytime you have to rationalize family, just remember if it's a single radical, something like this, you just multiply by the same radical, right? So this will be 2 radical 7 over 7. We can't simplify, so that's the final answer. And then when we have a binomial like our actual problem, radical 3 minus 1, we have to multiply by its conjugate. If this denominator was radical 3 plus 1, then when we multiply by the conjugate, that conjugate would be radical 3 minus 1, just to make sure that we're on the same page. Okay. Now we're going to get over to simplifying cube roots with exponents and variables. And I'm also going to do square roots just for practice for you all. So when we look at these problems, I'm going to be honest, family, they're typically not going to be this simple. So if we look at our first example, the cube root of 125x to the third. So if we remember, 125 is a perfect cube. 5 times 5 times 5 gives us that. And then x to the third, once we take this exponent and divide it by the root, that's just going to be x. So simplified answer should be 5x. Now let's say we had the same expression, but instead of a cube root, this was a square root. Now if we wanted to kind of break this down, this would be much different. So if we're breaking this down, we could use, let's put this all into one radical, 25 times 5. And then we could always keep x to the third as x to the third. Sometimes what I like to do is come in and kind of split it with the highest even exponent just to help me simplify it a little bit easier. So when we look, these are only two perfect squares that could come from up under the radical. So the square root of 25 is just 5, and the square root of x squared is just x. But under the radical, what we have left is only 5, and the last x term that would give us x to the third power. So this was a square root. Our answer would be 5x times radical 5x. Now when we switch over to our second example, same concept. So when we look at the cube root of 27x to the third, this is also going to be a perfect cube. So we know that the cube root of 27 is just 3. So again, very simple to simplify. This is just going to be 3x once we divide x to the third by the root of 3. So the answer would be A in this type of problem. But if this was a square root and we had 27 x to the third, the way that we could break this down would be radical 9 times radical 3 times radical x squared times radical x. Now the only two that we can simplify is radical 9 and x squared. Once we simplify, we're going to get 3x times radical 3x as a final answer. So whether we're dealing with cube roots or square roots, this is kind of how you could go about solving them. And you just have to understand the difference in how to simplify when it's a cube versus square. And it's typically just in multiples of 2 or 3. All right. So let me go on to the last topic of this live stream, and it's going to be solving radical equations. And I'm going to give you kind of the two most common scenarios which you'll see this. So the first one, we should always know with radical equations, we're trying to get rid of this radical. So for us to do that, we're going to be working backwards. So to get rid of the radical, that means we have to square it, right? And if we square that side, we have to square the opposite side. So we know exponent and radical cancel each other out. This is very similar to what we do on quadratic equations when we use the radical to cancel out the exponent. So we have x plus 3 is equal to 25. When we subtract 3, x is equal to 22. So our answer would be A. Now with this topic, always remember with radical equations that the answer you get may not actually be the solution. There's a possibility that it could be an extraneous solution, and we should have an example of that later on in this video. But when I substitute this back in, we have 22 for x plus 3 is equal to 5, or the square root of 22 plus 3. So this is going to be the square root, or radical 25 is equal to 5. Once we simplify this, what we're going to get is 5 is equal to 5. So we know that when x is equal to 22, it is a solution for the radical equation, and this would not be considered an extraneous solution. And I think this is going to be the last problem of this live stream, family. Thank you guys so much for joining us. If there's any questions or topics that you guys had on this video, please make sure to hit the comment down below for us in the comment box. We're going to try to get some of these topics into our next live stream. We're going to have a 1 and 2 weeks on the Algebra 1 Regents. This is also very similar to the EOC exam, and we're going to have a wider range of topics. So if there's something that you didn't see here tonight, please comment on one of our videos, especially this one. Let us know. We also have a new membership, guys, for those who have been asking about tutoring or even more support for testing beyond the EOC. Just check that out as well. You can find the link in our channel. It will also should be in the description. So when we have a radical equation like this right side, you have to pay attention to because it's not going to be like the last problem. So when we have radical x minus 1, and this is equal to x minus 3, we know the first step we want to come in here and get rid of this radical by squaring, and then we're going to do the same thing to the other side. But when we square, just please do not forget that this is a binomial expression. So as a binomial expression, that means when we factor, we should have a trinomial. So we have x minus 1, that's going to stay the same. And this right here is going to be x minus 3 times x minus 3. And just a quick rule of thumb, I said this in my videos before, but if you watch me, you guys need to learn these, not even tips or tricks, but these shortcuts. So when you have the same expression, right, the perfect square trinomial, all you need to do is understand this: a plus b squared. And this is going to be a squared plus 2 times ab plus b squared. So if we look at this here, right, we have x minus 3. So we know x is a and 3 is going to be b. So when we expand, let's go back to blue. All right, we know a squared, which is x, is going to be x squared. When we have 2 times ab, we have 3x. When we multiply ab, we multiply 3x by 2, negative 6x. And then when we square b, which is 3, this is just plus 9. So this is where we should be after getting rid of the radical. Now that we've done that, we're just going to solve like a regular equation. And I'm going to do this all in one step. So we're going to subtract x, right? And we're going to add 1. So on this side, we have 0 is equal to 2. And now we have x squared minus 7x plus 10. And I like my 0 on the right side, so let's just rewrite this. So now we're going to factor this, and this is going to turn into x minus 5 times x minus 2. All right, this is equal to 0, and when we check our answer, when we multiply, it'll give us the positive 10, and when we add, it'll give us negative 7. So x minus 5 is equal to 0, so I know x is equal to positive 5. And then my second answer choice, x minus 2 is equal to 0, so I know x is equal to 2. So this will be the answers for the radical equation. But before we go, we have to double check if any of these will be considered extraneous solutions. So let's say I use my first x, which is going to be, let's use 5. So we have radical 5 minus 1 is not equal to 5 minus 3. So we know the right-hand side is equal to 2, and the left-hand side, we have radical 4. When we simplify that, the square root of 4 is 2. 2 is equal to 2. So we know when x is equal to 5, that is a solution to the radical equation. When we check our second x, which is going to be 2, right, we have radical 2 minus 1 is equal to 2 minus 3. So we have the square root of 1, which is just 1, and this is equal to 2 minus 3, which is negative 1. So when we compare this answer, 1 is equal to negative 1, we know that this will be considered an extraneous solution. So when we plug it back in, it actually does not satisfy the radical equation. So that's going to be it for today's live stream review, family. We really hope that these topics were helpful for you. If it was not, please make sure you comment down below or on any of our videos so that we can get out more helpful content and the right content that you guys would like to see. We really thank you guys so much for continuing to watch and support Algebra with Mr. Peters. We're going to be bringing back live streams full in effect. Next time, we're going to be back here on September 24th, 6:30 p.m. We're going to leave the live stream open for about another 30 seconds to a minute just to make sure that anybody doesn't have any questions before they go. And like we said again, thank you guys so much for continuing to watch and support Algebra 1 with Mr. Peters.